Chapter 3, Alternative Venting Systems. With chimney venting, the flue gases travel through the heating appliances and up the venting system because hot gases naturally rise. Today's high-efficiency appliances absorb much more heat and produce lower temperature flue gases that do not rise as quickly or as reliably as they do with older, less efficient systems. One alternative to chimney lining is to install an alternative venting system that does not rely on high-temperature flue gases. This chapter will explain two types of alternative venting systems for non-condensing oil heat appliances. They are power venting and direct venting. Both are often referred to as sidewall venting. With power venting, a fan attached to the flue pipe where it exits the building pulls the flue gases out of the heating unit. With direct venting, the static pressure created by the burner pushes the combustion gases through the heat exchanger and out of the building. Sidewall venting offers several advantages over chimney venting. It enables a stable flow through the combustion system, and there are no cold chimney problems. It has a lower initial cost than a chimney. Less floor and wall space is used. It minimizes backdrafts, and it minimizes standby losses. Both methods of sidewall venting require pre- and post-purge cycles. For direct venting, the primary control must have a valve on delay and burner motor off delay feature. For power venting, the primary control must have valve on delay and burner motor off delay features, and/or the vent must have a control kit that provides pre- and post-purge cycles. This next section gives more detail on both power venting and direct venting. Power vents are mounted near or on the outside of the building and pull the combustion gases from the appliance using negative pressure. They require controls that interlock with the appliance control circuit to ensure that proper draft is established before the oil burner is activated. A power vent control system includes a draft-proofing switch and either a thermal or timed post-purge cycle. It's important that only stainless steel power vents be used with oil heat systems. Aluminized power vents do not hold up when installed with oil heat appliances, and are only recommended for gas appliances. Power vent systems are available as a combination unit that can also supply outdoor combustion air to the burner. These units combine the benefits of power vents with those of air boots that were explained in Chapter 1. A power vent system pulls combustion gases to the outside, creating negative pressure in the vent pipe. Here's how it works. A call for heat energizes the power venter, which is A in this picture. Negative pressure is established, closing a pressure switch. The burner is activated and combustion gases are exhausted. After the call for heat is satisfied, the burner shuts off, and the power vent continues to operate, exhausting residual flue gases. When the post-purge timer or temperature control is satisfied, the power vent shuts off. Power vents are sized based on the input firing rate of the appliance and the equivalent feet of vent pipe for the installation. If the power vent is being used for multiple appliances, it must be sized based on the total firing rate and the total equivalent feet of all the connected appliances. To determine the total equivalent feet, refer to the charts in the manufacturer's manuals to determine the total equivalent feet for each type of fitting used in the venting system. Calculate the total length of straight lengths of pipe. Add the equivalent feet of the fittings to the total length of the straight pipe to determine the total equivalent feet of the vent system. Find the total equivalent feet to determine the proper model for installation. In this chart, a 6-inch 90-degree elbow is shown to be equivalent to 11 feet of vent pipe, and a 6 by 4-inch reducer is equivalent to 4 feet. Note that draft control tees do not have equivalent feet. They simply count as a piece of straight pipe. A 4-foot-long, 6-inch draft control tee counts as 4 feet, not the 38 feet listed in the chart. As an example, an appliance with a 6-inch flue that includes two 6-inch elbows, 5 4-foot lengths of flue pipe, and one 6-inch by 4-inch reducer has 46 total equivalent feet. If the calculated equivalent feet is greater than what is specified for the power vent model being used, increase the diameter of the vent pipe or use the next sized larger power venter. This chart shows that the maximum equivalent feet for the SWG-4 model used with the burner firing at 0.85 gallons per hour is 35 feet if a 4-inch vent pipe is used, 65 feet if a 5-inch pipe is used, and 100 feet if a 6-inch pipe is used. The location of the terminal vent of a vent system must comply with the manufacturer's instructions, NFPA 31, and the local authority having jurisdiction. In general, it must be at least 7 feet above grade when located adjacent to a public walkway. It must be at least 4 feet below, 4 feet horizontally from, or 1 foot above any door, window, or air inlet into a building. It must be at least 3 feet above any forced air inlet located within 10 feet. The bottom of the terminal must be at least 1 foot above finished grade or the anticipated snow load. It must not be mounted directly above or within 3 feet horizontally from an oil tank vent or gas meter. And it must be at least 3 feet from the inside corner of an L-shaped structure. Vent risers are available for basement installations where window well is used, or in a situation where the vent terminal cannot be mounted to maintain the minimum clearance above grade or the anticipated snow load. The proper procedures for adjusting a power venter are found in the manufacturer's instructions, and typically they include the following. Set the choke plate on the power vent to its fully open position. Some power vent systems have the choke plate on the inside of the power vent unit, and some are adjusted on the outside of the building at the power vent. Set the control adjustment to its midpoint position. Then fire the system and let it run for 5 to 10 minutes to stabilize the stack temperature. Check the appliance manufacturer's specifications for draft over the fire and at the breech. Then close the choke plate on the power vent unit until the draft above the draft control reads approximately negative 0.04 inches greater than the recommended breech draft. Adjust the barometric draft control to obtain the appliance manufacturer's recommended draft at the breech and over the fire. The draft control gauge should be at open approximately half its full swing during normal operation. If the proper draft cannot be obtained at the breech, or if the gate does not open as described, adjust the choke plate to reduce or increase the airflow. Then readjust the draft control to obtain the required draft. Once the proper draft is obtained, perform a smoke test and adjust the burner air intake if necessary to obtain zero smoke. As the air intake is adjusted, the draft may change. If it does, repeat steps 4 through 8 to readjust the draft control and choke plate before continuing. Calculate the combustion efficiency and verify it is at the manufacturer's recommendation with zero smoke. Measure the exhaust gas temperature at the power vent inlet and confirm it is within the manufacturer's recommendation, typically between 200 and 500 degrees Fahrenheit. If the manufacturer's recommended efficiency at zero smoke yields a temperature below 200 degrees Fahrenheit at the inlet to the venter, the following suggestions should be considered. Increase the firing rate if the appliance manufacturer's instructions allow it. Insulate the flue pipe to minimize heat loss. Seal the flue pipe joints to reduce uncontrolled dilution air. And minimize the vent length from the appliance to the power vent system. And finally, adjust the pressure switch by doing the following. Turn the adjustment screw clockwise until the burner shuts off. Then slowly turn it counterclockwise until the burner starts, and then turn an additional 1/4 to 1/2 turn. A power vent system should be inspected and maintained according to the manufacturer's guidelines. During the annual maintenance, the service technician should check to be sure the motor and fan rotate freely, lubricate the motor and fan shaft with the lubricant specified by the manufacturer. The use of a non-approved lubricant often leads to premature failure. Inspect the power vent wheel and clean out any soot, debris, or coatings that inhibits either rotation or airflow. Remove and clean the air sensing tube, and inspect all vent connections for tightness, evidence of corrosion, and/or flue gas leakage. Then replace, seal, or tighten all of the pipe connections as necessary. Check the choke plate to ensure it is secure in place. Check the barometric draft control to ensure the gate swings freely. Check the safety system devices. Start the heating system, and then disconnect the pressure sensing tube from the pressure switch. This should stop the burner. Reconnecting the tube should restart the burner. Correct all deficiencies found and adjust the appliance to the manufacturer's specifications. Now, let's take a look at direct venting. Direct vent systems are OEM specific to the individual oil heat appliance. They are not a retrofit application. Direct vent oil heat systems use the power of the burner fan to push products of combustion through the appliance to the venting system and out of the building. They require high static pressure burners, and outside air is used for combustion. Unlike chimney venting and power venting, the appliance exhaust is under positive pressure. If there is a leak in the exhaust pipe, products of combustion will leak into the building. The intake is under negative pressure and must be sealed according to the appliance manufacturer's instructions to prevent chamber pressure imbalances that lead to nuisance lockouts. It is always important to follow the manufacturer's instructions, but special mention is made here because the appliance manufacturer's instructions may be significantly different from those of a component manufacturer. For example, consider this statement from PB Heat. PB Heat LLC requires that the vent slopes down 1/4 inch per foot towards the vent terminal. This takes precedence over the requirements shown in the Z-Flex manual. If the installer followed the flue manufacturer's instructions rather than the appliance manufacturer's, the appliance may not operate properly and/or may present a safety hazard. The installation criteria for a direct vent system is similar to those for power vent systems with a few differences. All joints on the positive pressure venting system must be sealed with a high temperature sealant rather than screws. The combustion air T is not a positive pressure location. It must be attached with screws and sealed or taped. The combustion air seams and joints must be sealed to avoid nuisance callbacks. Combustion tests must be taken at the port provided on the unit by the manufacturer. Do not puncture the stainless steel vent tubing. Adjust the burner for the highest carbon dioxide, but no more than 13% while maintaining a 0 smoke spot. Pressure or draft over fire and inflow cannot be adjusted. However, draft and/or pressure measurements must be taken in these two locations and recorded for reference.